Hey, hello and welcome to today's GFG prompt. The way of uploading well. So let's say today's prompt for flood fill algorithm. Okay, so what the prompt is saying is we are given with a 2D grid image, okay, where each cell represents a color of a pixel. Okay, okay. Now we will be given a coordinate basically, okay, a coordinate representing the starting pixel and a new color and a new color. So what we want to do? So whatever is the color, the original color at this coordinates, at the given coordinates. Okay. So we want to change them. We want to change all those connecting color pixel at this particular, whatever is the color at this particular position with the new color. Okay. All the connected. And how, for example, if SRC, in this case, SR is 1 and SC is 2. So what is SR? SR is 1, that is the second row, and SC2, that is the third row, right? So this particular pixel, right? This particular pixel. So what we want to do is we want to replace the color one with the new color two. Okay. And we want to replace all the adjoining or all the connected color pixels. Okay. So we have to go about left, right, top and bottom. Okay. We want to replace all those color pixels. Okay. So that's what is asked. Okay. Okay. Now how can we solve this problem? So it is like DFS. Okay, so what we are going to do here is we are going to take this color. Okay, we are going to change it to 2, and we will go to all the neighboring, right, top, right, left, bottom. And if the color is 1, if the color is original color, then we are going to replace it with the new color. Okay. Now, for example, now there can be some base cases wherein if the new color itself was 1, right? So there's no point because the original color at SRSC is also 1. So there's no point in replacing the one with the one because it is going to the same. So we can return from there. Okay. So this is the intuition behind solving the problem. So we'll just go and code. I think you'll understand better. So before going to the code, I'll just request you please subscribe to the channel, like the video. Okay, let's quickly start. So in n equal to, first I'll show the Java code followed by C++, image.length, then in m equal to image of 0.length. Okay. And then what we are going to do, DFS, since it is like we are going def first search. Okay. Or maybe let's name it properly, flood fill utils. Okay. Flood fill utils. And let's call image. Then we're going to pass what? Now, what is the original color here? So original color which we want to replace is SR, image of SRSC. Whatever is the color at this particular position, we want to replace them with the new color. And then what is the start? The start and the starting coordinates are SR and SC. That is from these coordinates, from the cell at these coordinates, we want to replace we want to replace with new color. Okay, new color. And then let's send the original color as well. So okay, so here image of SRSC is the original color, and we want to send N and M as well. Okay, and the new color. Okay. Now what we are going to check here first, the base condition is going to be if image of SR and SC. Okay. The source coordinates, if it is same as new color, then there's no point in going ahead and replacing the same color. Okay, right? With the new color, the same color. The result will be the same, right? So we'll return image here from here. Okay. And what we're going to do here, void flood fill utils in image. So yeah, so this is the original color which we're going to replace. Then these are the source coordinates. Then we have our N and M and a new color, right? In new color. Okay. Now what we're going to do is, so for example, let's say now image of SRSC contains the original color, right? So we have to replace with new color, right? We want to replace with new color, and once done, we want to also check for the neighboring cells, right? For the neighboring cells, image color, right? Original color. Then SR plus 1 will go to the right, SC N M new color. So SR minus 1, that is we are going to the left, and then we have to go to the top, which will do minus 1, and you are going to go to the bottom, plus 1, right? We have, okay. So this is like the main business logic, the core business logic, right? We are changing the color, we are replacing the color, and then checking for the, we are checking for the, we are checking for the original color and we'll replace for the rest of the, like if the neighboring nodes have the original color, we'll replace with the new color. Okay. So first, we also want to check, right? Also want to check is if image of SR and SE already contains, that is, we have come to the cell where it was replaced with new color, or image of SRSC, right? SC does not contain the original color, right? We don't want to replace the cells with which has different colors apart from the original color, right? So here we are going to we are going to return from here. Okay, this is one of the base condition. Second base condition, that is the core base condition, is if SR has become less than 0, or SC has become less than 0, or SR has become greater than equal to n, or SC has greater than has become greater than equal to m, right? If such is the case, then we are going to return from here, right? So these are the two base conditions. When it comes here, that means the cell contains the original color and we want to replace with a new color. And rest we are going to the neighboring nodes, neighboring cells, and we are replacing over there. Okay. So that's it. And finally, what we want to do is we want to return the image, right? Whatever is a modified image, right? So let's compile this. Let's submit it. If the test cases are being passed, thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. So here's the C++ code. First, the base condition. If the cell itself is new color, then return image, no point in replacing the color. Then we're taking NNM. We are calling our DFS. Okay. And here we have two base conditions. If the boundary is violated, right, then we return from there. Or if the cell was already replaced with new color, right? That is, we have come again on the same cell after replacing. And if the cell itself does not contain the original color, then we don't have to replace with new color. So we'll return from here. Here it will come when the cell contains the, that is, image of ij contains the original color, right? We are replacing here, and then we are going to the neighboring nodes. Okay. So this is it. I hope you've got the solution. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.